I'm Bill Herman for IMTS TV, and welcome to another edition of Shop Talk. Our guest today is Koepfer, the editor-in-chief of Production Machining magazine. Chris, welcome.
Thanks, Bill. Good to be here.
I thought we'd start with some fundamentals to get started, but what is production turning?
Production turning is actually a vestige, or the originator, if you will, of high volume turning of simple parts. The historical moniker for it was the screw machine industry, and it was very reflective for 100 years that you made screws, you made nails, you made simple parts in high volumes, primarily on parts of rotation, things that could be turned. Over time, that market has grown in sophistication. Screws still get made, but in addition, they've learned that technology, which is based on what I call progressive machining, where you take an operation that takes a certain amount of time and you divide it over spindles, for example. In a multi-spindle, you may have 6 or 8. So you take a cycle time that would occur on a single spindle machine and you're able to divide it by 8, which means that every time that part, that spindle, indexes, one complete part comes off. So your cycle time is divided by 8. It's very fast. Increasingly, that technique of progressive machining is being applied on a broader basis with more complex parts. That's why we call it, we named my magazine Production Machining, because it's reflecting that it's more than just turning, but turning is still at the core of what production machining is about.
And in terms of the technology, what trends are you seeing that are being implemented in production turning today?
There's a lot. One of the unique characteristics or demographics of the screw machine industry from which production machining has grown was that the machine tools were cam actuated. They were mechanically made to move using cams. And again, for close to a century, that was a very adequate way to produce high volume parts very, very fast. As CNC technology has grown, evolved, and proven itself, it is increasingly being applied to traditional screw machines. Categories such as Swiss type, multi-spindle, trunnion type rotary transfer themselves, inline transfer. Much of that technology is based in cams and is now being done in CNC. By implementing that, the shops that do that manufacturing, that machining, are now looking to do additional things. The coin of the realm being G-code, which is the fundamental part of CNC. If you can do G-code on a 3-axis machining center, you can do it on an 11-axis Swiss type. It's really kind of blurred the lines between the traditional screw machine cam actuated demographic and the CNC-based machine shop demographic. So shops are now looking to do additional operations, including EDM, grinding, again, machining centers, milling, that historically they wouldn't have done. They'd have stuck to production turning, but now they're able to expand their operational capabilities to satisfy their customers on high production parts. Yes.
And when we think back to its origins, when we're thinking of screws, we're thinking solid part. But there's secondary operations that are allowing fluid, like maybe a hydraulic piece or something, that's allowing a fluid flow, or those things are all incorporated in the high production?
You can do it several ways. You can bore it from a solid to create a tube, or you can use tube stock and start from that. There's many ways to do it. Bottom line being, though, is that you're able to do many more operations and try to reduce and eliminate your secondary and tertiary. The idea is to have it on the primary machine tool, and that's where some of the technology that we're seeing at the show here is just going crazy. Multitasking, let's call it that.
Exactly. And what is some of that technology that you're seeing here, that whether it's by brand name, if you're comfortable doing that, or the type of machines, what are some of the things that are most relevant to the readers of Production Machining magazine?
Several new things that we've been seeing over this year and a couple of shows back, perhaps, let's say, is let's start with Swiss type. Okay, Swiss type is becoming a very, very popular machining technique, not just for screw machine derivatives, but for machine shops in general, because it's a unique way to process using a sliding headstock, which means you basically have the Z-axis feed in the headstock, and you have basically a plunge cut in your X-axis. It's a little more accurate, considered to be, but it also enables you to bring many, many more tools into the cut, both on the back side and on the front side, and with pick-off spindles, which are now on all these machines, you can do back working and front working all in one operation or one handling, and that's a goal, is to eliminate those secondary operations. In addition, we're seeing lasers, for example, being applied on Swiss-type machines. Several manufacturers are demonstrating that here in the hall, and what that enables you to do is things like replace an EDM operation, which would have been a secondary, if you've got a medical part. If you want to etch the part, you can go ahead and put your name or the serial number or the traceability numbers on that part. You can do some cutting that you couldn't really do any other way, but the key is you can do it on the machine in a single handling. Taking that sliding headstock concept a little further, you're going to see in a couple of booths the sliding headstock concept applied to the multi-spindle machine. So what you're doing now is you're taking a sliding headstock and multiplying it by 8 inside a spindle drum, which gets you into that progressive machining curve again for high volume production. It's really, really interesting. Again, all enabled by the application of servo and CNC technology.
You touched on lasers. We had Industrial Laser Conference here yesterday, presented by the folks at the Laser Industry of America, LIA. Is that becoming increasingly prevalent inside of the machines in your arena?
It is, it is. And
is the price point coming down?
That I couldn't say, I don't know.
Yeah.
But I deal with the technology. But
let the others write the checks.
They write the checks and they sell the stuff. But the applications, the laser technology itself has become so compact and reliable and controllable. That's another key, is the depth of cut of a laser. Think about LASIK eye surgery, for example. You don't want somebody boring a laser beam through your skull. You want it to cut just as deep as it's programmed to do. And that technology applied in metalworking allows you to peel off just the layers of metal or material that you want, like an onion.
We talked briefly about automation. Let's talk a little bit about digitization being applied inside of production turning. What are you seeing in that space?
Digitalization is coming. It's important. Ironically, it's kind of always been there. What we're doing is kind of discovering these little gems of data available in the CNC control, for example, that kind of resided there, but we didn't really use them. Now we're finding ways to extract that data and upload it to places that can do an analysis of that data for comparative purposes. I've got machine 1 here that's running 99%. I've got machine 2, which is identical, running 85%. Why? We take that data and we do an analysis saying, okay, maybe it's because the operator takes a break at a different time. You don't know unless you really take a look at it. And that data is trackable and capturable, and that's part of what digitalization is doing on the shop floor. In addition, the idea of MT Connect, for example, is coming. Virtually any machine that you see on the floor, if you ask, you'll be told is IIoT enabled. That means it can be hooked up to an MT Connect kind of a platform and be connected throughout the shop using a language common so you can analyze the accessories, for example, the bar feeder, the coolant, the chip conveyor, all the ancillary performances as they impact the overall cycle time and running of the machine.
Obviously a big buzz here at the show has been additive. We're seeing more and more of it, just comparing from 2 years ago. It's interesting as we view things in 2-year increments that the leaps that go forward in capability, in speed, in cost, and certainly its presence here at IMTS has grown. How is that affecting production turning? Is it being implemented?
Slowly, I'll say. For my audience and the shops I go and visit, they're very curious about additive, and rightly so. And what I'm seeing being done, and I think it's probably a wise way to approach it, is I'm seeing some shops that are curious who will go out and buy a 3D printer, let's say, a relatively inexpensive, maybe just a commercial kind. They'll bring it into the tool room or into the programming area, and they'll let the guys play with it. They'll let them make whistles on it, let them make different things for their kids, and use it the way it was kind of intended initially. The goal being to familiarize them with what it can and cannot do, what kind of programming is required, what kind of CAM is required, and the goal being to upscale that. Where I am seeing it also applied, let's say in the metals, is in the tool room, making fixtures, one-offs, two-offs for the shop itself.
Right.
But I don't see it yet quite ready for the medium to high volume prime time.
Speed issues?
Speed issues.
Right.
Yeah. And again, shops are very busy right now, and it takes some time to be able to implement a new process, especially a very foreign process such as additive versus subtractive, which everybody's been doing.
Well, I like the concept you just mentioned about getting an additive printer in there, letting them play with it.
Yes.
I think some shops paralyze themselves when they read all about the digital journey and what we need to do. They view it as all or nothing.
Right.
So they can't afford the all, they don't have the time or the money for the all, so they do nothing. And I like the idea of stepping into it a little at a time.
Sort of an analogy or story, if you will, that I can remember from earlier in my career, when the first wave of robots hit, which was in Unimation, Cincinnati, various ones. They were, again, not quite ready for what their promise was. They couldn't really deliver on the promise, and this is back in the 80s. But it was funny because so many shops would buy a robot. They'd say, I got to have a robot. Everybody's doing a robot. But they had no idea what to do with it. Many cases I saw robots sitting on the loading dock of a shop on a crate, on a pallet, because they bought it, but oh, now what? And I'm not saying that's what additive is, but the point is that there is technology that will have to find its way in certain markets.
Have you seen several of your readers here, several of the customers?
I have. One of my customers, advertisers, populates his booth with his customers, which are my readers. So instead of having his sales guys walking up and down the aisles, he has several of his happy customers talking to attendees as they come into his booth, which I think is extremely smart.
Very credible.
Yeah.
Yeah.
And
I've never heard of that.
The guys identify themselves. They're happy to do it. They get to attend the show and work the show at the same time. Again, very clever approach. I like it.
We've got about 2 minutes left. What are some of the challenges? Are there some things on the immediate horizon facing high production companies?
Yes.
What would some of those be?
Absolutely, the top is personnel.
Yeah.
It's personnel. And of course that's endemic in the entire manufacturing arena.
Right.
And there's a lot going on. I've written many lines of words about this issue. The best solutions that I'm seeing are being done on a local level. My readers interfacing, let's say, with their local vocational schools,
Right.
maybe with their trade association, like an AMT, like a PMPA, which represents the precision turn parts industry, machine parts industry, and working through those auspices to try to get some help. I've got a good friend of mine in Cincinnati, works for a very fine company. He set up an apprenticeship program through the auspices of a local vocational school, and it's feeding him people and allowing them to see what he does. It's not a Dickinsonian hellhole like everybody thinks. I also think the Manufacturing Day, which is coming up in October, excellent opportunity.
You've been watching Shop Talk. Our guest today has been Chris Koepfer, the editor-in-chief of Production Machining Magazine. For IMTS TV, I'm Bill Herman.